arm that has a temperature probe to test the water to see if it's good enough for a baby to use. It says if this is less than 32 degrees, then it moves the arm to turn the faucet so that more hot water can be added. On this one, if it's greater than 92, it moves the arm so that it can add more cold water because the baby could get scalded. And if it's just right, the arms won't move at all, and you can just set your baby in.
And our robot is robotic. And the purpose of our robot is to make music.
Our group we use the right side of the coordinate plane to determine where our robot will be displayed on the screen of our robot. On the rover side, we display the X and Y coordinates to determine where the music note will be displayed on the robot.
The ultrasonic sensor, it can tell how many inches away the wall is from the note, and that's when it plays her note. On the screen, if it is here, so choose a letter. And she got it wrong, so it's a sad face.
Tutorial.
Huh?
Tutor.
This is, yeah. But she got it right, so it's a happy face. And,
Alright, pretty much the big thing about this is that it recharges itself. It's able to navigate to the butterfly is able to navigate to the flowers by means of infrared communication. Once it gets there, brackets on the front are able to connect here, which actually recharge the battery because it's connected to the battery and it creates an electrical circuit. We have it so that the flowers also are able to dynamically change how much power they're giving depending on how much they are, how many times they're used. So it sort of acts like a real flower in that it doesn't have unlimited nectar. Alright, right now it's demonstrating the use of energy so that its batteries are more depleted. And in just a second we'll see it try to navigate to the flower to find more energy. That's what it's doing now. No, the time is not.
What the frick? Plug it into the robot. You forgot to plug it back into the robot.
Sorry,
plug it in.
we forgot to plug it away.
Okay. Go.
Alright, so right now it's just showing the use of energy. Alright, now it's navigating, and it connects to the thing, and right now it's recording its battery. And that's pretty much the main thing about our program.
So our program, it has the boom raise up through the Bluetooth communication and then raises the hook. Once that's done, the robot will follow the line and go to the line that we designated the code for properly place the power wherever we desire it to go. So as you see now, it skips the first line, it's designated, goes to the second line. These silver lines that you see, it picks up that when they stop at points, and it'll decide, depending on what we designated in the program, which turn to make. We had it set to the second track, so it'll see this first silver line and skip it, and for the next one, then it'll make the turn. And then as it makes the turn, then it reaches the silver line, and it will drop the car. And then that complete the trip. Simulating picking up a car that's been damaged or whatever reason needs to be towed, and then dropping it off to this place like an impound or a machine shop where it can get fixed. The other aspect that we made with our robot is using Bluetooth. We made a remote control, and so it uses the rotations from the motors and sends messages to the robot, which will then convey to the drive motors, going forwards, backwards, and turning it side to side.